Welcome to my channel Learn, Grow and Rise. In today's session, we will discuss one important periodic property, that is electron affinity or electron gain enthalpy. But make sure before watching this video, you must watch my video on periodicity. I have given the link in my description box. Now let us know what we will discuss in electron affinity. We will discuss what is electron affinity, successive electron affinity, unit of electron affinity, factors affecting the magnitude of electron affinity, periodic trends of electron affinity, and lastly, I have given few questions in exam decode session for practice so that you can crack your board exam easily. Now, let us discuss what is electron affinity. Electron affinity is the amount of energy released in adding an extra electron from outside to an isolated neutral gaseous atom in its lowest energy state to form a gaseous monovalent negative ion or anion. Now, you can see here the example of the chlorine atom. We can easily isolate the chlorine atom from its neutral gaseous state, because we know that in the gaseous state there is a very less force of attraction between the atoms, so we can easily isolate one atom. When we isolated the atom, that must be in its lowest energy state. We know that the electronic configuration of the chlorine atom is 287. So it needs one more electron to attain the nearest noble gas configuration, and when the outermost electron becomes 8, it will gain the stability configuration. So chlorine atom accepts one electron from the outside, and while accepting the electron, the amount of energy released while adding the extra electron from the outside to the isolated chlorine atom known as the electron affinity. And after adding the electron, the configuration of the chloride ion will become 288. The outermost cell contains 8 electrons, so it will become now stable electronic configuration. So when while adding the electron in the chlorine atom to form the Cl- ion, the amount of energy is released, that is 349 kilojoule per mole. So the 349 kilojoule per mole is the electron affinity of the chlorine atom. The negative sign indicates that energy released during the process. Now let us discuss what is successive electron affinity. Successive electron affinity means the addition of the electron from the outside to the outermost cell one after other. When we add the first electron in the outermost cell, that is known as the first electron affinity, and its value is always in negative, means energy released in this process, hence the process is your exergonic, because electron when enter to the outermost cell, because the nucleus attracts that electron and hold that electron tightly. During this process of work done, the energy released, and that energy released is known as the electron affinity. Let us see this example. Suppose this is one atom and it consists of one cell, and the central part is the nucleus. When we add one electron from the outside to this nucleus, to this atom, what will happen? The nucleus exert the force on the electron added, and due to the force of attraction, the electron added smoothly in the outermost cell. So while the adding, the work done takes place, and during the work done, energy is released, and the amount of energy released during the process of the work done is known as the electron affinity or EA1, because we are adding the first electron to the outermost cell, and the process is always exergonic. The energy released may be in the form of the heat or maybe any other form. When it released in the form of the heat, we call it as the exothermic reaction or exothermic process. Now let us discuss what will happen when we add another electron to its outermost cell. Suppose I need to add another electron or the second electron to the outermost cell. Then during the process energy will release or not? Let us check. The energy will not release. Rather, we need to give some energy to put this second electron in its outermost shell. Why, children? Because when we add the second electron, at that time we need to add the electron in the minus A. Suppose this is the atom A and this is the, after addition of the one electron, its configuration, the atom become the ion, and the ion form, symbol of the ion will A minus. So we need to add the second electron in our A minus ion. In A minus ion, the electron density is more. When the electron density is more, there is a repulsion between the electron present already and the electron added. So, to keep our second electron, to avoid the repulsion, we must require to give some energy to make it stable. Hence, the second electron affinity, or when we add the second electron, the amount of energy required to place the second electron is now the electron affinity, or EA2. So, the EA2 value is always positive. Now, let us check this statement with the help of one example. The formation of the oxide ion, children. You know the oxygen atomic number is 8 and the electronic configuration is 2,6. So, oxygen required 2 electrons to attain the nearest noble gas configuration or to make the outermost shell electron octet. So, for that reason, when we put the first electron, the amount of energy released during the process is your 141 kilojoule per mole. But when we add our second electron to the O minus ion, in O minus ion, children, you can see there is already one negative charge is there. Why the negative charge is there? Because electron density is more. So when we place our second electron to that outermost shell where the electron density is already more, so definitely there is the inter-electronic repulsion between the electron present and we have added the electron. For that reason, the amount of energy we need to give to place successfully the second electron in the outermost shell. So, what is the amount of energy required here? The amount of energy required here is your 780 kilojoule per mole. Hence, the EA2 is always greater than 0, or that is always positive. Now, let us discuss how can we measure the energy of electron affinity. Electron affinity energy can be measured by using the unit electron volt per atom, or kilojoule per mole, or kilocalorie per mole. Now, let us discuss the factor affecting the magnitude of electron affinity. The first factor is atomic radius. Electron affinity is inversely proportional to the atomic radius. Means when atomic radius increases, electron affinity decreases. Smaller the atomic size, greater the attractive force, extra electron added. Where the attractive force on extra electron added. You can see the example here. Here you can see two atoms. First atom, this is the first atom and this is the second atom. The first atom consists of your two cells. This is the first cell and this is the second cell. And the second atom consists of the three cells. Of course, when the number of cells increases, the atomic size increases. When the atomic size increases, the distance from the nucleus to the outermost cell increases. So, here the distance from the nucleus to the outermost cell increases, means the second atom is greater than to the first atom. So, atomic size of the second atom is greater than the first atom. Is it clear, children? So, when the size increases, when the distance increases, the attractive force by the nucleus on the electron added decreases. When the attractive force decreases, it cannot be placed, or the electron added cannot be placed successfully. The more the attractive force or attraction by the nucleus on the electron, the more successfully the electron can be placed in the outermost cell. The more successfully the electron can be placed on the outermost cell, the more amount of release during the process. Hence, the electron affinity increases. Now, let us discuss the second is that your nuclear charge. Nuclear charge is directly proportional to the electron affinity. When the electron affinity increases, the nuclear charge also increases. Why? As the nuclear charge increases, the force of attraction between the nucleus and the outermost cell or the extra electron added increases. Hence, the electron affinity increases. Now, let us discuss the periodic trends of electron affinity. First trend is across a period. Across a period means when we are moving from left to right in a period, then what will happen to the electron affinity? The electron affinity increases because the atomic size decreases and nuclear charge increases while moving from left to right of the periodic table. I have taken one example of this is the second period. In the second period, you can see as the atomic number increases, then the electronic configuration, the number of cells remains same. But as the nuclear charge increases, the atomic size decreases. Atomic size decreases along a period. As the atomic size decreases, then what will happen? Atomic size decreases and also nuclear charge increases. What will happen then? Then your electron affinity increases. You can see there is two exceptions, that is in beryllium and that is in nitrogen. So group 2 and group 15 they show the negative value, they do not show the negative value and they show the exception. The electron affinity does not show a regular trend along a period because a number of exceptions. The exception is your group 2 and group 15 because they do not show the negative value. Why, children? Because in group 2 element, so here in group 2, what is the element present? That is the beryllium. And let us write the electronic configuration of the beryllium. Beryllium electronic configuration is your 2 and 2. Outermost is stable. Outermost cell is stable because it contains the 2 or duplet. Hence, when we put one electron in a stable configuration, so it is very difficult to put one extra electron in a stable electronic configuration. So in this case, if we cannot place the electron successfully and we want to place this electron in its outermost cell, we need some energy to keep our electron in its outermost cell. In that case, the energy will not release, rather we need to give the energy for the successfully placement of our electron. Why? Because the stable electronic configuration. Why it is stable, children? Because you can see when the outermost cell contains duplet or 2 electrons in the outermost cell, the configuration is the stable configuration. This is the stable configuration. Due to the stable configuration, the EA value is your negative. Now, let us see in case of your nitrogen. What will happen in case of the nitrogen? Now, in nitrogen, the atomic number is your 7. So, it is 2 and 5. But 5 is the number of electrons present in the outermost cell. But when you in the higher classes you will read the cell also divided into the subcell. Okay, and here the subcell you can see it divided into 2 subcell, and first subcell contain 2 electrons and second subcell will contain 3 electrons, and this 3 electrons shows a half-filled orbital. Shows a half-filled orbital. And this half-filled orbital, why it is half-filled, children? Because the maximum capacity of second subcell. Let me write. The maximum capacity of the second subcell is maximum capacity of second subcell is 6. So when it is 6, here you can see 3 electrons are there. When 3 electrons are there, it is half-filled, and it is half-filled. And as it is the half-filled orbital, it shows the stable configuration. So it is difficult to place the electron in the stable configuration. Hence, it do not show the negative values. It shows the positive value. Now, electron affinity of the element with a stable configuration such as noble gases has a 0 value. So all the noble gases, they show the 0 electron affinity due to their stable electronic configuration. Hence, they do not accept the electron as they have completed their octet. Now, the halogen are the highest electron affinity, and alkali metals have the least electron affinity in a given period. Now, let us discuss it is down a group. On moving down a group, both atomic size and nuclear charge increases. But the atomic size is dominant over the effect of the nuclear charge increases. Hence, the electron affinity follows the trend of the atomic radius or atomic size. So, as we moving down the group, the atomic size increases. As the atomic size increases, then the electron affinity must be decreases. You can see it is 3.6, and it is an exception in case of the chlorine and fluorine. Now you can see there is a gradual decreasement of the electron affinity because atomic radius that is increases. Atomic radius increases, hence electron affinity decreases. But why there is an exception in case of the fluorine and chlorine? Now let us see. Halogen have the high electron affinity value. What is the reason? Due to the small size and high nuclear charge, high nuclear charge of halogen in a period. First point. Second is that halogen have the 7 electrons in its outermost shell, so it need 1 electron less than or 1 electron to complete its octet. So the tendency of accepting the electron is very high in case of the halogen. Hence, the electron affinity is more in halogen. Now let us discuss why electron affinity of chlorine is more than fluorine. But by the law or by the rule, the fluorine must have highest electron affinity. But here the thing is that the size of the fluorine is very less. Hence, there is the electron density in the outermost shell is very high in case of the fluorine. So, there is a inter-electronic repulsion between the electron already present in the fluorine atom and the electron added. Is it clear, children? Due to small size, high nuclear charge and the high electron density in the outermost shell. Why electron density is more? Because of the small size. So, because of the small size, the electron density is more. So, when we add 1 extra electron to the fluorine, there is a inter-electronic repulsion take place. Hence, the electron affinity of fluorine is less than that of the chlorine. Now, let us discuss or practice few questions in my exam decode session. The first question is that electron affinity of the element on moving down a group dash increases or decreases. Now my second question is that among the period 2 elements dash has the highest electron affinity, fluorine or neon. Electron affinity is the amount of energy released during the formation of dash cation or anion. Second electron affinity of an element is always less than 0, greater or lesser. Children, please take a pause, write the answer, and after that you just see the answer I have given here. The first is that the electron affinity of the element on moving down the group. When we moving down the group, the electron affinity decreases because atomic radius increases. Among the period 2, the element has the highest electron affinity, that is fluorine. Electron affinity is the amount of energy released during the formation of the anion. Electron affinity is directly proportional to this. It is directly proportional to the nuclear charge. Second electron affinity for an element is always less than 0. It always greater than 0 because the value is positive. Now hope children, all of you like my video, so please do not forget to like, share and subscribe and hit the bell icon. Thank you.